Hello, and welcome to part 2 of solving trig equations. We're going to continue where we left off in part 1, and that is going to be solving some basic trig equations. So in example 645, we're going to solve the following equation, again on the interval from 0 to 2 pi. So here the only difference is that now I've got a sine squared of x in my equation instead of just a sine to the first power. I'm going to go ahead and show you this as if there were no sign in the equation. So what I'm going to do is I am going to let a represent my sine of x. So what I have is 2 times sine of x, but in place of sine, I'm going to put a. And this equation has my sine being squared, so my a should be squared, and then minus 1 is equal to 0. And this is fairly straightforward to solve. I add the 1 to both sides as my first step. My goal is to isolate the a squared. So 2 times a squared is equal to 1. Now since I want to isolate the a squared, I divide by 2, and I get a squared is equal to 1/2. Now to undo that square, I square root both sides. And that leaves me with on the left-hand side a, and on the right-hand side I could have a positive or a negative square root of 1 over square root of 2. And I will simplify this all the way down. Positive or negative square root of 1 is 1, square root of 2 is 2. And since we will be using the unit circle, I want to go ahead and rationalize to make sure that I find the value of theta on the unit circle. So I'm going to go ahead and rationalize and write this as square root of 2 over 2. And all I did there was multiply the numerator and denominator by square root of 2. So in this case we would be done. We would have solved for my a value. That won't quite be the case in our other example, but we're going to follow similar steps to at least get down to that rad 2 over 2. So I'm going to start by isolating my a squared, in this case it is sine squared, and I'll do that by first adding 1 to both sides. When I do that, I've got 2 times sine squared of x is equal to positive 1. Now again, I want to isolate my sine squared, which is being multiplied by 2, so I will divide by 2 on both sides. And I've got sine squared of x is equal to 1/2. Now, just like I square rooted my a, I'm going to go ahead and square root my sine. Sine is being squared, and I want to know what just sine equals, so I need to square root both sides so that I have just sine of x is equal to positive or negative square root of 1/2. And I will simplify and rationalize just like we did on the left to get positive or negative square root of 2 over 2. Now we are going to look for the value of x on the unit circle, or the angle on the unit circle, from 0 to 2 pi. That gives us a sine value of square root of 2 over 2. So I'm going to go back to my unit circle, and I am looking for a sine value or a y value of positive or negative rad 2 over 2. I see that occurs at pi over 4. I see it occurs at 3 pi over 4. I see it occurs at 5 pi over 4. And I see it also occurs at 7 pi over 4. So on the top, in the first two quadrants, I have positive rad 2 over 2. And in quadrants 3 and 4, I have negative rad 2 over 2. Since we are only looking in one rotation of the unit circle, I'm only going to have those 4 answers. So my angle could be pi over 4. It could be 3 pi over 4. In those two cases, I get positive square root of 2 over 2. It could be 5 pi over 4, giving me a negative square root 2 over 2, or it could be a 7 pi over 4. So these are the 4 possibilities for the value of x in this equation. In our next examples, we're going to be moving on to solving trig equations using a calculator. So what I'm going to do is follow the same steps, but the ratios that I obtain will not be on the unit circle. So in this example, I want to start by isolating my cosine function, which means that I need to divide both sides by 5. So I've got cosine of something is equal to 1 over 5. Now what I don't know is what angle on the unit circle is going to give me a cosine value of 1/5. So what I'm going to do is I'm going to use my calculator to help me identify that angle. So in order to use my calculator, I'm going to use inverse trig functions. So cosine of my angle equals my ratio, but if I use inverse cosine, I can input my ratio to get the angle. So cosine of my angle equals my ratio, but inverse cosine of my ratio will give me the angle that I need to get there. So I'm going to go ahead and pull up a calculator and evaluate inverse cosine of 1/5. And then once I've evaluated this left-hand side, I can then solve for x. Using my calculator on that left-hand side, I get 1.369 radians is equal to x plus 3. I was careful to use radians because they gave me my interval in radians. They want me to look for an angle theta between 0 and 2 pi. That's in radians. So therefore, when I use my inverse cosine, I need to make sure that I am working in radians. There is an option on your calculator to work in degrees, so make sure that your calculator is set to the mode that you would like to be working with, and in this case it is radians. Now another thing I want to talk about is that I want the cosine value of 1/5. So cosine of 1/5 means I want an x value on my unit circle where my cosine is a positive 1/5. So I look to where x is approximately 1/5, that might be about here. I see that that point would occur here on my unit circle, but it also would occur here on my unit circle. So I have two places where I have a cosine value of 1/5. Now this solution only gave me one place where my cosine value will be equal to 1/5, and that is at 1.369 radians. So if we're talking about positive radians, my angle here, theta, is 1.369 radians. But it could also be rotated in the negative direction to still give you a positive cosine value. My calculator didn't give me that option, but I need to make sure that I am finding both answers in the interval that inverse cosine is defined for, and that is negative pi over 2 to pi over 2. So there is a second answer, and I will go ahead and go backwards on my unit circle, negative 1.369 radians, to get to that second point. So I have 1.369 or negative 1.369 radians. Both of these will give me a value of cosine that is 1/5. And now I solve, I subtract 3 from both sides, and I get a value of 1.631 for x, and I subtract 3 from both sides in my second equation, and I get a value of negative 4.369 is equal to x. So my x is equal to 1.361 or negative 4.369 radians. Go ahead and take a moment to pause the video and try example 646 on your own. So my first step is to go ahead and add 5 to both sides of my equation. So on the left I have 16 equals 20 times the sine of theta. I want to isolate my sine, so I divide by 20 on both sides, and that leaves me with 4/5 is equal to my sine of theta. Now, of course, I want to solve for theta on the interval from 0 to 2 pi, so we are working in radians. So since I want to solve for theta, I'm going to go ahead and use my inverse sine option on my calculator. So inverse sine of my ratio, which is 4/5, is going to give me the degree that I'm working with. So on my calculator, I punch in my inverse sine of 4/5, and I find that theta is going to be approximately 0.927 radians. And we are working in radians because I set my calculator radians since my interval is from 0 to 2 pi. So what I have found is that if I move around my unit circle 0.927 radians, I will have a sine value of positive 4/5. So that would be approximately here. Theta equals 0.927. Now when we talk about inverse sine, we talk about inverse sine on the interval from 0 to pi over 2. So if I were to draw out my unit circle the best that I can, there are two places where my y value is positive 4/5. We found the first place, but there also is a second place in the second quadrant. So I'm going to go ahead and need to use reference angles to find this second angle. That theta of 0.927 can be used as a reference angle to get to my y value of the second point. So that means that starting at my negative x-axis and going backwards, if this angle is 0.927, then I have a sine value of 4/5. So if I want to find what this angle is to get me to that second sine value, I'm going to take the entire interval from 0 to pi. So I am going to take the entire angle measure starting at 0 on the positive x-axis and going around to pi. So that red arc that I just drew has an angle of pi radians. Now if I want to end at the angle that gives me my sine of 4/5, then I need to back up by 0.927. So I'm going to go ahead and subtract 0.927 from my pi to determine the approximate angle that gives me my inverse sine of 4/5. Evaluating this in my calculator, I find that theta could also be approximately 2.215 radians. We were asked to find theta. Once we found theta, we are done. So these are the solutions to my equation. In example 647, we're going to continue this process, except now we're going to be looking at trig equations that have a quadratic nature. To make this a little bit more straightforward to start, I'm going to approach this with a similar tactic that I did previously, and that would be to take my sines and replace them with a more friendly variable, maybe a. So instead of sine squared, I would have a squared. Instead of sine, I would have a. So all I did is I let a represent my sine of theta. So I've got 2 times a squared plus 3 times a plus 1 is equal to 0. And this is a fairly friendly quadratic that we should be able to factor. When we factor, we will get 2a plus 1 times a plus 1 is equal to 0, which means that 2a plus 1 is equal to 0, or a plus 1 is equal to 0. So a is a negative 1/2, or a is a negative 1. Now they didn't ask us for a, we replaced our sign with a, so we need to make sure that we go back and we answer the question that they actually asked, which is, what is the value of theta? So sine of theta is negative 1/2, and sine of theta is a negative 1. So I'm looking for the places on the unit circle where my sine value is a negative 1/2, or inverse sine of negative 1/2 is equal to theta. There are two solutions that we are looking for, and those values would be that theta equals 7 pi over 6 and 11 pi over 6. Now generally we only look at negative pi over 2 to pi over 2, but they are asking us to look at the entire unit circle to find our values. Inverse sine of negative 1 is only going to occur at one place on my unit circle, and that would be at 3 pi over 2. So in this example, I've got 3 solutions for theta: 3 pi over 2, 7 pi over 6, and 11 pi over 6. And again, we have these 3 values because we are told specifically to look for all solutions on 0 to 2 pi. Thanks for watching.